Hello and welcome back. So we have just been looking at the effects, the things that can affect the rate of diffusion anywhere in the biological world. And we came up with this equation known as Fick's law. And actually, if you just know this equation, you'll be able to see there's a tremendous number of questions that you can answer well understanding this. So the rate of diffusion is directly proportional. That sign that looks a little bit like a fish or an upside down 8 with its bottom missing, that means proportional to. So it's directly proportional to what's on the numerator, indirectly proportional to the denominator, the thickness of the membrane. Okay, so let's have a look at some questions. What I'm going to ask you to do is just write down the answers and then restart the video once you are done. I will then go through the answers, and if there's anything that you haven't quite got correct, pause and make a note in your book so that you have clearly learned from your mistake and you don't make it again. That wonderful growth mindset. Okay, how did you get on with those? So looking at this graph P, the type of relationship, anytime you get that shape, it means it's inversely proportional. And that graph going up, you see that a lot in your physics graphs, it's directly proportional. The three factors that affect the rate of diffusion of a substance into a cell deep in the human body: the surface area, the concentration gradient, and the thickness of the membrane. Can you see how memorizing Fick's law, you can pull all the answers out of that? And then for each of your three factors, state which graph it should be plotted on. So thickness of membrane we know is inversely proportional, so it's going to look like graph P. And surface area and concentration gradient are directly proportional, so it's going to look like graph Q. Nice, gentle start. Okay, now in this question, a couple of calculations. Question 2 is pretty straightforward. Question 3, a little bit of challenge just because they're using different units and you have to make some conversions. So show your working, write down the answers, and when you are ready, play the video and we'll purple pen your work. Okay, how did you get along? Okay, so the first one's nice and easy. 2A, 0.25 gram per centimeter cubed. 2B, 0.01 gram per centimeter cubed. C, 75 centimeters cubed, which gives you 0.32 grams per centimeter cubed, so just that conversion there. And D gives you a final answer of 0.25 gram per centimeter cubed. If you've got any of those wrong, make sure you write in corrections and a note of why you went wrong and what you need to do. Okay, part 3, a little bit more tricky. So the final answer for 3A should be 12.5 gram per decimeter cubed. B is 2 gram per decimeter cubed. If you wrote gram / decimeter cubed without the negative, that's correct. So gram per decimeter cubed is how we say it either way. Part C, 0.25 gram per decimeter cube. And part D is 0.08 gram per decimeter cubed. How did you do? Still a little bit easy, still needing a bit more challenge? I love this. Let's give it a go. Okay, have a go at this. You are really relying on this equation here and your understanding of Fick's law. So take 2-3 minutes to write down the answers and then we'll check them. Show your working for this. Okay. How was that? I know some of you would have sailed through. Some of you might have found this a little bit more tricky. So the first one, the surface area is tripled. So if I have tripled my surface area, I'm going to triple my rate of diffusion. So my rate of diffusion is 0.04 micrograms per second. So I go 3 times 0.04, giving me my answer there. The next one, part 2, the thickness of the membrane is cut by 50%. Okay, so what do I have to do? If it's been cut by 50%, it's half of what it was. Okay, so what I'm going to do is I'm going to go 0.04 divided by that half. Now, there's different ways you can set this up to get to 0.08. In the example on the right, they've got 0.04 times by 2. As long as you get the answer, and don't forget the units. I purposely not put them in there so that I remind you that the units are absolutely important if they're not stated. Okay, the next question. The concentration difference is doubled and the surface area is cut by 30. So there I've got my rate of diffusion, my concentration. Oh, hold on. This question got mixed up. Okay, so let's go back over here. Okay, so my surface area is cut by 30%. So rather than it being 1, and if it was 1, it wouldn't affect the rate of diffusion because it's directly proportional, I have cut it by 30%. So now rather than 1, it's 0.7. Okay, that was a bit tricky there. And it says the concentration difference is doubled. So that's times by 2. So what I need to do is I take the 0.7 times that by 2, and then I times the 0.04 by that. So that gives me an answer of 0.056 micrograms per second. How are you doing? Part 4. Okay, the surface area is increased by 60%. So rather than it being 1, it's not doubled, which would be 2. It's increased by 60%, so we interpret that as 1.6. And the concentration difference is reduced to a half of the thickness of the membrane. The concentration difference is reduced to a half, so that's 0.5, and the thickness of the membrane is doubled. Okay, so I can put a 2 over there by the thickness of the membrane. So what I'm effectively doing, 1.6 times 0.5 divided by 2, and then I times that all by 0.04. And that gives me a final answer. Over there we can see 0.016 microgram per second. Okay, so it's all about that equation. And finally, the last question. Explain what will happen to the rate of diffusion in this section of alveoli when the person starts to exercise. So your answer should have something about it will increase because the blood will be moving faster, and so a greater concentration will be maintained. So the concentration difference is there. I hope you did well, and I look forward to you joining next time. Don't forget to subscribe to my videos so that I can beat Mr. Gregson, but also so that you have access to them anytime you wish. Have a great day. Take care of yourself. Bye-bye.